Following on from the previous video, I gave you a summary and then we got to this stage here where I asked you to establish whether or not this will converge or if it will diverge. Remember, at the moment, our knowledge of mathematics is not strong enough to work out the whole summation here. We can only make use of this. We can only make use of this to establish whether or not this thing here will converge or if it will diverge, because we don't know how to calculate the whole summation here. We can only make use of this to establish whether or not this will converge or if it will diverge. So to show whether or not it will converge or diverge, we would make use of Riemann's lower sum. So making use of Riemann's lower sum, this thing here would represent this. This thing, remember, we are starting at 1. So this thing here would then represent this. This thing here would represent this, and so on, all the way to infinity. So if you look at this here, at the moment, Riemann's lower sum is this thing plus this thing plus this thing plus this thing, all the way to infinity. We are missing this number 1 here. We are missing the number 1. So what we've got so far is Riemann's lower sum. So that's all these rectangles here. Would be all of these. Would be this basically. Here we are starting at 2 as opposed to 1. So because of this 2 here, this 2 here is really us representing everything from the second term all the way to infinity. From the second term all the way to infinity. So this thing here is everything here, everything to the right, from here all the way to infinity. We are missing the number 1. So all the rectangles, that's this thing here, would be less than or equal to the area underneath the 1 over x squared graph. So this is the 1 over x squared graph, this red line here. Well, the area underneath the area from 1 to infinity, that's this area here. So that's this area here. So the point here is that the area underneath the 1 over x squared graph will be greater or equal to all the rectangles here. By right, I'm pretty sure that the area underneath the 1 over x graph will be strictly greater than this thing here. But I also have the right to use greater or equal to. We are pretty sure that it's going to be greater than this thing here. But we do have the right to use greater or equal to. So we have a choice here. So let's just stick with this. We could use this, but I'm going to use this. Okay. So where were we? So this thing here will be greater or equal to this thing here. Remember that this thing here is from the second term all the way to infinity. We are missing the number 1. So currently this thing is less than or equal to this thing. So from here, add an equal amount to each side. Add the number 1 to each side. So add 1 to this side, add 1 to this side. That would then this thing here would represent this whole thing here, which is this thing here, the thing that we're trying to investigate. So at the moment, we've got this thing. At the moment, we've got this thing here, all the way to infinity. But from here, add 1 to both sides. Add 1 to both sides. Now that would include the 1. This thing here will include the 1, and that is this thing that we're trying to investigate. So from here, add 1 to both sides. That will then give you this. Okay, so now this thing here, we can rewrite it as this, because rather than starting from 2, we are now starting at 1. So from here, this thing is exactly the same as this thing. So once you're here, we've done this many times in the past. This thing here, the integral from 1 to infinity of 1 over x squared will converge. So remember, we've done this many times in the past. 1 over x squared, if you have a graph, a graph 1 over x squared, sorry, 1 over x, if you have a graph y equals 1 over x, when it's 1, this thing here is 1. Well, 1 over x squared, the integral of 1 over x squared from 1 all the way to infinity will diverge. It will diverge. We've seen this before. this here would diverge. But then if you have 1 over x squared, 1 over x squared will look something like this. 1 over x squared will look 1 over x squared will look something like this. It will, so this area here will converge. If you have the square root of x, it will look something like this. Hang on, let's start again. 1 over x looks like this. So this is 1 over x. The integral 1 to infinity of 1 over x dx here. This area here will diverge. But then if you have 1 over x squared, it will look like this. It will look something like this. And then this area here will converge. And then if you have square root of x, which is x to the power of a half, it will look something like this. And then this area here, the integral from 1 to this dx here, this thing here will diverge, this thing here will converge, this thing here will diverge. This is a critical stage here. Hang on. 1 over x is the critical one. And any power, if you have x to the power of 1.2, say, then this thing here will converge. If you have less than, let's say x to the power of 0.99, then this thing here will diverge. Well, we've done this many times in the past. You should be able to recognize that this thing here will converge. So 1 over x, I'm repeating myself, forgive me. So 1 over x here, 1 over x squared will look like this. This thing here will converge. This thing here will converge from 1 to infinity. So if you look at this here, at the moment we've got this thing being greater or equal to this thing here. Well, if this thing here converge, then when you add a finite number, when you add a single number to it, then the whole thing here will converge. So this thing here will converge, this thing here will converge, and then this being greater than this, well, this is less than this graph here. So this has to also this will have to converge as well. Now let's start again. This thing here being greater than this. Well, if this thing here is greater and it converges, then this being less than this will also have to converge. So by the way, so this thing must converge. Okay.